Hello. Today we are going to demonstrate our HIL SCADA environment. Typhoon HIL SCADA is a simple, easy-to-use graphical environment that allows you to create your own unique interface with the real-time model. For the sake of this presentation, we will open and compile our already created model from the Schematic Editor Introduction module. This model consists of a voltage source, a three-phase inverter, and an induction machine. Let's compile this model using the Compile and Load button. This function will open HIL SCADA automatically. If you don't have a connected device of the correct version, in this case HIL 404, you may get an error message. After you acknowledge the error, a pop-up will appear, letting you choose from several alternatives for loading the model in SCADA. Let's click on Load Model to the virtual device. The virtual device is a software module within the Typhoon HIL software toolchain which emulates Typhoon HIL 4 series and 6 series devices on a PC. Due to the software-based nature of the virtual HIL device, there is no external I/O support, and models are not run in real time. Once the device is loaded, a list of recently opened panels appears on the main screen. In addition, we can access the Command Toolbar, the Library dock, the Panel Explorer dock, the Model Explorer, the Model Settings dock, the Namespace Explorer, the Panel tabs, the Message Log dock, the History dock, and the Status bar. We will be using these toolbars and docks throughout the module. First, let's create a new SCADA panel and run the simulation. You can find the Start and Stop simulation buttons on the Command toolbar. On the bottom right, you can see the time of the simulation and the model of the simulation. Now we will be adding a few monitoring and action widgets to see and interact with the simulation. First, let's find a few measurement names from the model by looking for it in the Model Explorer tab. Let's insert machine speed and the measurement of the RMS value of the current. After dragging and dropping the measurement name into the SCADA panel, the widget wizard opens. In this wizard, we can choose which widget we will use to represent this value. The widgets that we can use are Gauge, Digital Display, Bar Graph, Trace Graph, Text Display, or Signal Data Logger. Let's use a trace graph for the machine speed, and a digital display for the current measurement using the widget wizard. Let's open the machine speed trace graph properties and change the advanced settings of the widget. In the Advanced Settings tab, you can find the plot settings, which define the X and Y axis text, the Y axis range, the time window, and the background color. In this case, let's uncheck Auto Scale for the Y axis range, and set the minimum and maximum range from -200 to 200. Widgets can also be added from the Library Explorer. Let's add another widget that will represent instantaneous speed quite nicely. For displaying the speed, you can use the Gauge widget. You can find it in the library, in the monitoring section. Let's drag and drop a Gauge widget. Let's open the properties by double-clicking on the widget. Let's rename it to Speed. Then, in the Signal Settings group, choose the name of the probe machine speed in the Analog Signal text box. After that, let's open the Advanced Settings dialog. Here you can set the measurement range, as well as the warning and critical range. Let's set the minimum and the maximum speed to -200 and 200 radians per second. Let's also set two critical ranges, one from 150 to 200, and the second from -200 to -150. We can see that there are zeros for the values of each widget. Let's enable the inverter. To do that, we need to use action widgets. Let's find Inverter Enable in Model Explorer dock. Model Explorer allows you to choose your widgets contextually, based on signal type, for example model input or output. Since Inverter Enable is an input to the model, we can choose between knob, slider, and text box widgets. Let's use a text box. To enable the inverter, we need to set inverter enable to 1. Let's write 1 to the inverter enable text box. This value will propagate and enable the internal modulator of the inverter. Let's do the same thing for torque T, only in this case let's use a slider. Let's stop here for a second and introduce the model settings dock on the right side of HIL SCADA. Here you can change all controllable variables from the model, such as sources, switches in the switching blocks, SCADA inputs, and any other types of model components you have included in your model. Also, here you can define all analog and digital outputs from the HIL device. Now let's go back to the SCADA panel. To find more properties of this slider widget, let's double-click on it to open the slider macro widget properties. In the basic settings you can find the name of the slider, description, slider properties, and macro code. Now it is a perfect time to talk little about HIL API possibilities. In the macro code section, you can use Typhoon HIL API functions. You don't need to be an expert in Python to use HIL SCADA to its full potential. Our API wizard teaches you both Python syntax and HIL API, by converting GUI commands to Python code. The API wizard is accessible when you are using the code editor, and can be turned on and off using the view menu. Inside the API wizard, you can find all control variables for model settings as well as capture commands and other commands, such as read analog signal and read digital signal. By clicking the Insert button, you can easily add your desired code. You can find more information about HIL API in our HIL API documentation. A link is included in the References section. Now let's return to the slider macro widget properties menu. Let's set the slider properties to -5 for minimum, 5 for maximum, and step to 0.5. And click OK. We can go to the library dock to find other interesting widgets. Here you can find widgets for action, monitoring, data logging, analysis, connection, and visual. One especially useful component is Capture Scope. Let's drag and drop the Capture Scope component from the library. Capture Scope is a special monitoring widget that enables you to easily capture desired signals for offline analysis, or to use scope mode to observe signals in runtime. You can use only one Capture Scope widget per SCADA panel. Now, let's enter the widget and add a few signals. Clicking Signals opens the Scope Signals Properties window. Here we can add analog and digital signals. Let's add analog signals of interest for us such as current on the DC link, line-to-line voltage, and machine current. To do that, click plus and let's add these signals. The Capture Scope window has up to 4 different viewports. Let's view each signal in its own viewport. To do that, we just need to check the checkboxes. Also, you can change the time interval for the viewports via the drop-down menu on the right. Capture Scope lets us perform a capture over some time interval. To do that, let's switch from scope to capture using the combo box. Clicking the small gear on the right side of the combo box lets us import all signal settings from scope. To the right are the Enable Trigger and Force Capture buttons. Also, let's change the time interval of the capture to 0.1 seconds. The maximum sample rate is closely related to the time step of the simulation. Now let's do a force trigger. You will find out more about Capture Scope in the User Model Interaction and Data Acquisition module. Finally, let's cover some last topics that may be useful. First, let's save this SCADA panel so we can come back to it later. This is done by clicking the Save a Panel File button on the command toolbar, or by navigating to the Save Panel button in the panel menu. SCADA panels are saved as .cus files. Just to the right of the Save Panel File buttons, you can find the Panel Initialization button. Here you can include various Python libraries or set the initial values for model settings. Besides Python libraries that come with the software installation, HIL SCADA allows you to import additional Python libraries. These Python libraries can relate to co-simulation tools, communication protocols, machine learning libraries, and much more. This means that HIL SCADA not only enables you to interface with the HIL device, but other equipment in the real world. This mode is known as standalone HIL SCADA and comes pre-installed as a separate application. However, for working with a HIL device, you should generally use HIL SCADA from the main software screen. With this, you have gained a basic overview of how to build the SCADA panel and how you can use it to parameterize and control a model. Feel free to experiment with the other widgets at your disposal and build the SCADA panel you need. For some interesting demonstrations on practical applications of HIL SCADA using these tools, check out some of our application note resources below.